Hello friends, I am Boyobde and you are watching Unplanned Pulse. Most people think infinity is just infinity, a never-ending line. But in 1891, mathematician named Georg Cantor proved that some infinities are actually larger than others. Today, I am going to show you how he proved it, and then we are going to build a Python script that demonstrates the magic behind it. Imagine you try to list every decimal between 0 and 1. It might look like this. Here I have taken 4 numbers, but you can take as much as number you want to check it. Let's just look at the first 4 digits of 4 numbers. Now let's see how we can always find a missing number according to Cantor. Nothing, just by looking at the diagonals. Now just change the diagonal elements I have marked. First number has 2 at first spot. I will make it 1. Second number has 4 at second spot. I will make it 1. Third number has 8 at third spot. I will make it 1. And fourth number has 3 at fourth spot. I will make it 1. I have taken all of them 1, but you can take any number as you want. Now, if you write a number taking all the replaced position number, you will get a new number. As you can see, it is a unique number. It has no similarity with the other 4 numbers because I changed the diagonal digit for every row. So my number is guaranteed to be different from every single number you wrote down. Now let's automate this logic in Python. This is the code to perform Cantor's idea. Now let's understand how this code actually works and implements its idea. In part 1, you can see I have taken the lower and upper limits of the interval. This defines the range in which all our numbers must lie. If user enters 0 or 1, number should look like 0. So the integer will fixed and only decimals vary. In part 2, if high minus low not equals to 1, we ensure the length is exactly 1 or not. As Cantor's argument works on intervals like 0 to 1, 2 to 3 or 5 to 6 because all numbers share the same integer part. N's input is taken to define how many numbers will be in our list or user want to insert between the given range. Numbers equals to third bracket closed. This is a list which will store all numbers entered by the user. And next we have 2 instructions which will help to work the program without any problem. In part 3, for range in n, I run this loop to take n numbers, 1 number per row like a table. And the inner loop, while true, this loop keeps asking until the user gives a correct input. To check if input is correct or not, I have used a try block here. And there is val equals to float of num. It converts the input into a point number. Next, if not low less than value less than high is true, then the number is not in range. If this condition is false, then there is no problem. Next, if dot not in number, if this is true, it means the number don't have a decimal part, and if it's true, then parts equals to number dot split dot or decimal part equals to parts 1. Using this, we split the number into integer and decimal parts. Now after taking decimal part, have to check if it contains equal of n numbers or not, as it is important for the condition of Cantor's rule. If length decimal part less than n, this condition is true, then error will occur as the number of numbers user have given as input must be equal to the decimal part numbers. If all conditions are successfully checked, then there is number dot append num to store the number into the numbers list. If the given input is not a number, then it goes to the except block. And if all inputs are given perfectly, then it will move to the part 4. In part 4, there is new number equals to str low plus dot. This is to start building our new number. In part 5, for I in range n, this loop is to apply the condition of diagonal trick. In the loop, decimal part equals to number of I dot split and 1. Here it will take the decimal part of the ith number. The next digit equals to decimal part of I. This selects the ith digit of ith number. So for first number it will take first digit, and for second number it will take second digit, and so on. This forms the diagonal. And next, if digit is equals to 1, new number equals to new number plus 2, else new number will be equals to new number plus 1. This step will change the digit, which will ensure the difference from the original number. And finally, in part 6, the loop for num in numbers print num will print all original numbers inputted by the user, and the last line will print our missing number. So this is how the whole code will work. Now let's see the working code by running it. Now let's run this code. Okay, I have taken the lower limit as 0 and upper limit as 1. Let's say I want to input 4 numbers, and here you can see there are 2 informations that you should strictly keep in your mind. So first input will be 0.1111, next input will be 0.2222, 0.3333, and the last one I am going to give is 0.5555. So here you can see the code is perfectly working. And what if you are giving a wrong number? For in that case, the code will work like this. Suppose you entered after point 3 numbers, but you should enter 4. So see, here you have a output must have at least 4 digits after decimal. So the code is perfectly running. That's all for today. Thank you for watching. If you found this video helpful, don't forget to hit the like button, subscribe the channel and share it with your friends. See you in the next video.